Welcome to session 3. Previously in our last class, we covered the topics of variables, statements, and loops. You can effectively think of these as microcomponents. Today, however, we're going to discuss macrocomponents, aka larger entities, that are made up of those smaller bits. To start off, we're going to cover functions. You will notice that all starting main.rs files have a fn main. This is the main default function that automatically runs when you compile and execute your Rust project. However, this isn't the only kind of function that you can have. We can create other ones, like so. We start with the fn keyword followed by the name of the function, followed by parentheses, then bracket. This effectively allows you to partition your code base and create reusable code that you can trigger back in the main project by procking like so. You can even have inputs and outputs in your function, which allow you to specify the conditions in which your function is procced, as well as return data back. How exactly do you do this? Well, we place temporary variable names along with their data types in the parentheses to serve as inputs, and the type of data, aka output, that we want to return in the parentheses after the arrow. As for how you can call the function, we just provide their respective values like so. And then they are automatically matched to these temporary variables, which we later access inside the supporting clause by name. Just remember, if you intend on having an output of some kind, to return it using the return keyword, followed by the associated variable/value that you want to send back outside. You can then later store this output, like so. The important use cases of functions will be covered in more detail later. Moving onwards, it is now time to discuss objects, which in Rust operate mainly off structures. Similarly to how functions are a higher level version of statements, objects are a higher level version of variables. And objects are cool because they allow us to create entities with various characteristics similar to how things are in real life. For example, I can create an object that represents a person and make it have subvariables, which in turn represents that person's characteristics, such as height and weight. To do so, we start with the struct keyword followed by the name of the object followed by bracket, and then inside add in the subvariables starting with their names followed by colon followed by their data type. We can then create instances of this struct like such: capital P person, bracket, 68, 160, bracket. And then store a reference to the object by attaching it to a variable, let person A, and we're done. You can then access this object served variable in this manner: person A.height or person A.weight. But we can go one step further. We can even attach functions to structs. To do this, we start with the impl keyword, followed by the name of the struct which you intend to attach the function to, and inside the bracket, you place in whatever function you like just as before. Here's an example: fn hello parentheses, bracket, println hello. Which we can then trigger via person A.hello parentheses, semicolon. That said, you might be asking yourself, why would you ever want to do this? The answer is that sometimes you might want to trigger a function that uses the same subvariables associated with the object itself. For example, we might want a function that calculates the ratio between a person's height and weight. We can do this by passing the object subvariables as inputs to the functions inside the object itself via &self. Note, the &self is a special type of input that's really only used in object function cases. Thus, the name of this variable is mandatory. Then, you can reference these subvariables via self in the form of self.height or self.weight, treating it as if the self stood for the name of the instance of the struct in question when called. So then it's quite simple. We just return self.height divided by self.weight and make sure to add the data type of this output here. Why was all of this so important? It was because a lot of the time we use open source code bases, aka crates. By linking dependencies in the cargo.toml file, we can use functions that other people have created to share with the world to use. All you need to do is add one line here and refer to the documentation. Alternatively, you can create some of these yourself, or access functions across files. This can then be thought of as an even higher abstraction of functions, of statements. To start, we just create a new file like so, and add in our functions. Then in our main.rs file, we just use the mod keyword followed by the name of the file and end with a semicolon at the top of the page. To call the function, we just preface it with the name of the file, followed by colon, followed by function name, parentheses. Just don't forget your inputs if you have any.